Welcome Math 9. Today is 9.2, solving single-step inequalities. And you're going to solve inequalities exactly the same way that you solve equalities, which have the equal sign, except this. Switch the inequality when you multiply or divide by a negative number. So pause, write that down, and then pause as you need to, write these equations, and give them a try as you can. So I'll do the first one, and then probably you'll be able to try the next couple as we go. So we're going to solve as if this is an equal sign. We're just going to think that in our mind. So take away 2, negative 5x is greater than or equal to 10. Divide by negative 5. I'm dividing by a negative, so I'm going to switch this sign. Divide by negative 5, and x is less than or equal to negative 2. We'll see the verify in a second, but for now we'll just do the solve. So try these next two. And here we go. So divide by 4, negative 5 over 2 is greater than x. And we just leave the x on the side that it is on, like we've always done. And now probably it's more conventional for them to write it in the direction with x starting first. So x, and now read from your x, is less than negative 5 halves. So let's write that x is less than negative 5 halves. Okay, next, number 3. We need the x by itself, so times by negative 8 on both sides. If I'm going to times by a negative, my sign will switch, and now I'll have 8 is less than negative 24. Okay, you're verifying with the inequality is a little different than verifying with an equality, which has the equal sign. An inequality, you need two parts. So pause, write that down. And now here we go. So the first one, we'll verify the boundary. And the boundary is the equals number. So we'll use equals in the equation. And we'll use the number that we came up with for an answer. And I shouldn't be pointing there. I should be pointing up here. So we got x is less than or equal to negative 2, so I'll do x equals negative 2 in the boundary. Then I substitute and solve exactly the same as I do with a regular verify. So 10 plus 2 equals 12, and 12 does equal 12. Yay! Okay, the second part, we have to verify the symbol, so greater than in this case. And if it's a greater than or equal, you just do the greater part because we already took care of the equal in the first verify. So now we need an x, and we're going to pick something that will fit in this solution. So something that's less than negative 2. Let's pick something easy. Negative 3 would be less than negative 2, and that's easy. Here we go. So negative 5 times negative 3 plus 2 is supposed to be greater than 12. 15 plus 2 is supposed to be greater than 12. And 17 is greater than 12. So hooray, now we know that our solution here is correct. Okay, let's do the second one. And this is on page 354, and it's the B part. So they say, here's your lovely equation, and here's the solution that we got. Verify that solution. So verify the solution for in each equality. If incorrect, what is the solution? Okay, so let's erase this little part. We don't need that quite yet. And they've already solved, so don't solve, just use their answer. We're going to verify the boundary, which is the equals part, which means x is going to equal negative 6, even though it's not an equal here. It's fine, the boundary is always going to be an equal. And it goes, so negative 5 times negative 6 is supposed to equal 30. 30 does equal 30. Okay, super. Next one. Now I'm going to verify the less than symbol that I got for my answer. So I'm going to pick something. X is less than negative 7. So something easy. How about x is equal to negative 7? Sorry, did I say 7 up there? 6 there. X equals negative 7. So don't pick something like x equals negative 385.76 because it's just painful for you, and an easy number will do the same thing. So negative 5 times negative 7 is less than 30, plus 35 is supposed to be less than 30. That's not true. So a slash through it means not the symbol, so not less than, which means our answer is not correct. Here's what you know. Because your boundary was verified, that means the number itself is right, but your symbol didn't verify. So your symbol is wrong. And let's look when we actually solve the question and see what happens. So if I solve negative 5x equals 30, and you pause, do it, and then let's do it together. So see if you were thinking the same thing. Divide by negative 5, divide by negative 5. Whoops, I shouldn't have had equals, neither should you. Sorry. Okay, go back. X is less than 30. There we go. So x is less than, oh, whoops. If I divide by negative, my sign is going to switch. Greater than negative 6. Oh, and that's exactly what it looks like happened to them. They forgot to switch the sign. And now that would verify in our second verify. Next, they're going to ask you things like, does the given value satisfy the equation? So we're not going to verify on this. We're actually just going to substitute it in and see if what they gave us works in the equation. If it works, it makes the equation happy or satisfied. You can think of it that way. So let's do, if I have 3x plus 7 is less than or equal to 16, and they say x equals 1. Does x equals 1 satisfy the equation? So I substitute in, and then I see if it works. It's like a verify. So 3 plus 7, is that less than or equal to 16? 10, is that less than or equal to 16? And yes, that's true. So we would say, yes, x equals 1 satisfies the equation. You can say that in your mind, and you don't need to write out the whole thing. You'll just need to write yes, probably just yes in your book, but think of all of those words because that will help you memorize satisfies. Okay, this is going to be 355 now, and this is a nice story question. So Yvonne is planting trees as her summer job. Lucky. She gets paid 10 cents per tree. She wants to earn at least $20 an hour. Notice they already have the 10 cents as $0.1 and then $20 per hour. Those have to be in the same units. Sometimes they'll try to trick you there. How many trees must she plant per hour in order to achieve her goal? And let's read the ABC. Write an inequality to model the number of trees Yvonne must plant to reach her goal. Great. Will the solution be a set of whole numbers or a set of integers? And explain. C. Solve the inequality and interpret the solution. Okay, I think we're going to do B at the very end, so we'll just leave it till last. A part. Write an inequality. Okay, so she plants how many trees? So how many trees is going to be our x? If she makes 10 cents, so 0.1 times x times how many trees she plants, she wants more than, so greater than or equal to, she wants at least. Yes, at least will include the number and go up. So greater than or equal to 20. Let's solve this for C, and then we'll think about B. So divide by 0.1, divide by 0.1. X is greater than or equal to 200. So she's got to plant at least 200 trees in order to make $20 an hour. Then let's think about B part. Will the solution be a set of whole numbers or integers? Well, if she plants 200 or 201, or 202, 203, 204, or if she doesn't make her goal and plants 150, etc. Those are whole numbers, but they're also integer numbers. Let's think about integer numbers. If she plants, let's say, -5 trees. Oh, yeah, not possible. So we must have things that are whole numbers, because that's all she can plant. And then we would make a nice sentence like she needs to use whole numbers, or it will be a set of whole numbers, because you can't plant -5 trees. Okay, and that is it for today. So enjoy your questions and be good. See you later.